In this video, I'll provide an introduction to random variables and the normal distribution. Research involves examination of relationships among variables. Any of these might be a variable in a particular study. The loose definition of a random variable is one for which exact values are not known until data are collected. Using this as a guide, let's consider which of these variables might be random. Treatment groups are assigned by the researcher, so this would not be a random variable. Values are known before data are collected. You can't know a person's heart rate or weight before collecting data, so these would be considered random. Aspirin dosage would be a random variable if subjects are surveyed and asked how much aspirin they take. But if the researcher assigns subjects to different aspirin dosages, then it's not random, because the researcher determines these values in advance. The remaining variables would all be considered random, as one would not know their exact values until data collection. More often than not, random variables are outcomes, or dependent variables. Another way to think of random variables is that the values we get represent a random sample of all the values we could have gotten. There are two types of random variable: discrete and continuous. Discrete random variables have gaps between values. You can own one car or two cars, but you really can't own half a car. Continuous random variables, on the other hand, can potentially take on any value within a given range, and are limited only by the precision of the measurement instrument. For example, we weigh ourselves to the nearest pound or half pound because that's how precise our bathroom scale is. But weight can take on an infinite number of values between any other two values. Random variables have distributions. Probability distributions are theoretical and show all of the potential values for a random variable. They are also derived mathematically. For example, the probability that a fair coin lands heads when it is tossed is 0.5. If we toss a coin 4 times, we can count the number of times it lands heads. And if we repeated this an infinite number of times, we would have its probability distribution, the probability for each potential value of number of heads in 4 tosses of a fair coin. This is a random variable because we don't know what value it will take until we collect the data. But we don't have to toss the coin in order to know how likely these values are, because this can be determined mathematically. These probabilities sum to 1, or 100%. We can also view the probability distribution as a histogram. Probability is a proportion, or an area under the distribution. The total area is a probability of 1, or 100%. The bars are contiguous because this is a quantitative variable. And because the bars are all the same width, we can just look at their height to determine probability. There are two major theoretical probability distributions that are used in inferential statistics: normal and binomial. The normal distribution is often used as a model for continuous variables, and the binomial is a common distribution for modeling discrete variables. Because we refer to samples when describing our data and populations when testing hypotheses, we need to distinguish characteristics of a population from those of a sample. When we refer to a population, these characteristics are called parameters. And when we refer to a sample, they're called statistics. Parameters are described using Greek letters. The mean is mu, the standard deviation is sigma, and the variance is sigma squared. Sample statistics are described using English letters. The mean is x bar, the standard deviation is s or sd, and the variance is s squared. This is the normal distribution. It is bell-shaped and symmetric, and the mean, median, and mode all fall at the middle of the distribution. It is also asymptotic, meaning that the tails approach but never actually meet the x-axis. The area between any 2 points indicates the probability of getting values within that range. This distribution has a mean of -40 and a standard deviation of 10. We can use these parameters to determine probabilities for any range of values using a formula. We could find the probability, for example, of getting a value between minus 25 and minus 15, or a value less than minus 60. The problem is that we'd have to calculate probabilities every time the parameters of the distribution change. Another problem is that the formula isn't exactly comprehensible. Fortunately, any normal distribution can be standardized. What this does is change the original mean and standard deviation to a standard form with a mean of 0 and a standard deviation of 1. Then we can use a table of probabilities for a standard normal distribution. No matter what the original mean and standard deviation, a standard normal distribution has a mean of 0 and a standard deviation of 1. To summarize, a random variable can be thought of as one for which exact values are not known until data are collected. All random variables have probability distributions. There are two main types of random variable: discrete and continuous. The normal distribution is used as a model for many continuous random variables. We distinguish between parameters, that is, characteristics of populations, and statistics, characteristics of samples. The parameters of a normal distribution are its mean and standard deviation. Finally, any normal distribution can be standardized, which allows us to determine probabilities.